We're going to be spending a lot of time with classical and empirical probabilities. But before we move on, there are a couple other ways to find probabilities that we want to just discuss briefly. One is a simulation. So imagine the scenario I mentioned earlier where you want to take the roulette wheel that we have for example 1, and you want to imagine spinning that roulette wheel 1,000 times. Now, if you were going to physically do that, I mean, it might be fun, well, at least for a while, but it'll start getting really tedious. You're likely to make a mistake, you're likely to screw it up, you'll lose track, you'll lose count, etc. And it just takes forever to sit there and do it by hand. Whereas you could make a computer do it. A computer could spin 1,000 times really fast, randomly select, from these 38 numbers 1,000 times really quickly. I could get a computer program to do that in very little time. That's a simulation. When you don't want to do the experiment yourself, but you want to make a computer do it for you, assuming that the computer has systems that all are in place that'll make everything nice and fair, which is a big assumption to make. It's the kind of thing that you spend your life working on if you're in a computer science degree, that kind of thing. All right, so that's a simulation. So sometimes you do it because it's just tedious to do. Sometimes you do it because it's unsafe to actually run the experiment. So for example, I've seen probability experiments about, what would happen if a tsunami wave hit this coast, or what would happen if this bad traffic accident happens? What's the ripple effect on all the traffic in the area? Stuff like that. You make computers do that because it's way too dangerous or impractical to do it in real life. I'm not going to invent a tsunami just so I can have it smash against a coast to see what occurs, right? There, I just made an example of each type. So the top type is more, it's unsafe to do it. I mean, practical, you can't do that. You can't have a tsunami smash into a building unless it actually happens. The bottom one is more like you could do it, but who in the world would want to? I've actually played games with people when they get really frustrated with the dice. It's all the dice's fault for not rolling the way I want. Like, I want to roll these two dice 10,000 times and see how fair they are, right? Well, you can do that with a computer really quickly, right? Toss two dice 10,000 times, no problem, right? Take less than 30 seconds with a computer. Heck, less than 10 seconds. All right, the other type of probability, so you only worry about this stuff if you're a computer programmer or somebody who works in upper level probability and statistics. So since most of us aren't going to be there, we don't have to worry about that. The other kind of probability is a subjective probability. This is a probability that expresses an opinion or a degree of belief about how likely a particular event is to occur. So it's not obtained from an experiment. It's not something you can replicate. It's more the unrepeatable things in life. So you kind of make an educated guess based off of what you know about the situation and kind of hope for the best. So it's for all the non-repeatable events in life. They're perfectly legitimate. I mean, sometimes they're the only method available. If it's the only method available, then so be it. If you can't make a simulation for whatever reason, or you can't come up with data that specifically talks about what you're looking at, then fine, so be it. All right, so let's compare the three types of probabilities here. We have the classical, that's that hypothetical, imaginary, like it's by logic. I'm going to logic my way through this. Empirical is going to look at data, look at real life observations. And subjective is the kind that you're making an educated guess because what you're looking at is not repeatable. It's never happened before, it'll never happen again. It just is this one-time thing. All right, so a friend tells you there's a 60% chance they'll be attending Julie's party this weekend. Right, so that's subjective, right? That's not a repeatable process. They're just kind of making an educated guess based on their feelings at the moment. So that would be subjective probability. Um, I let's say you're a prognosticator on the news. What's the chances that so and so will get confirmed as a judge by the United States Senate? Well, that's subjective, right? So you're kind of making an educated guess, but every judge's confirmation hearing is unique, right? So the makeup of Congress is unique. So what happened before cannot be applied to what's happening now, etc. So those are subjective probabilities. The Red Cross in Jackson keeps track of the blood types of everyone that donates blood. Um, all blood banks do. They need to know what the area around them looks like and what percentage of people are donating different types of blood. They estimate the chances that the next person will donate or to donate at the drive will be type O negative is 8%. Of course, O negative is a very important blood type because it's the universal donor. So if somebody comes into the emergency room with like a gunshot wound or something, they need O negative right away to give that person blood before they can figure out what blood type they are. So the important words in this is keeps track. Since they're keeping track, this is empirical, right? They're gathering data on all of us, as they should in order to be an effective blood transport system. They have to know what percentages they're going to get. And it actually does vary a touch from country to country. It's kind of an interesting medical study, an area of interest if you're interested in biology. All right, the probability of rolling a 7 or 11 on two six-sided dice. Well, unless you're going to have the computer roll the dice for you, that will be classical, very much classical. So classical probabilities is, here, let me type that up. Classical probabilities are you're hypothetically just kind of imagining this, right? You didn't collect any data, you didn't run the experiment. Simulations kind of run into empirical, right? So if you make a computer do it for you and then track it, then you're kind of gathering data from the computer. So we're not doing that. We're just hypothetically imagining this. All right, a researcher administers a new drug to cancer patients, and the proportion of people for whom it worked is counted. The probability, that counting thing, that sounds important. The probability that the new drug is effective for new patients is determined by these numbers. Right, that would be empirical again, right? So they're counting, they're keeping track, as they should if they're going to try to get some kind of new drug approved. Then we hope that they are counting and paying close attention to what they're doing. Sorry. There, I highlighted the answers a little bit so they'll pop. All right. During the World Series of Poker broadcast. Oh, I love watching these. These are fun. So you watch them on ESPN and everybody's wearing, sunglasses and trying to intimidate each other around a table. It's good times. So you can watch it on ESPN. They'll have a gambler they have little cameras on the bottoms of the tables, and so the camera sees the gambler's hand, their cards or whatever, and next to their name it'll like show their name, like Tucky. I'll imagine myself as a poker player. So Tucky, and it'll say 88% next to my name, which is my chance of winning the hand. Not my chance of winning the pot, because of course betting is a different thing in poker, but my chance of winning the hand based off of what everybody has and what I have. So that's classical probability, right? It's actually tracked by computer, but it's not a simulation. It's just classical probability because the computer knows all possible combinations of all poker hands. It can keep track of all of that, and it knows the probability of me winning the hand, hypothetically speaking, would be 88% because it knows all the possibilities, hypothetically. Right? It's not based off of other poker hand data. It's actually based off of the hand itself, off the cards. Right? And that is the classic definition of classical probability. Again, that's how it was invented by Bernoulli and Cardano, wanting to gamble to make a living and not tell anybody how they were doing it. All right, last but not least, a commentator on CNBC states that they think next year's unemployment rate will be 5.4%. Oh boy, is this subjective. Very, very, very subjective. Every political pundit, or in this case, CNBC, that's the business one. So, business pundits, political pundits, they are full of subjective probabilities. Because everything they're talking about is based on events that are not replicable. Everything that went into making this year special and unique, I mean, there's literally millions and millions of things, all the people involved, and what the government's like, and what's this country versus that country, and what's the government there, and what's the economy here, and what's the price of oil this year, and what's the price of potatoes this year. And I mean, literally millions and millions and billions of things go into making an economy. So when they say what they think next year's unemployment rate's going to be, they're kind of making an educated guess, usually based on a couple things. But they're talking about a system that, one, they can't gather full data on because it's impossible. Two, they couldn't they really just can't. They can't gather data, and they can't hypothetically think about it. They're just making an educated guess, but everything that they do is not built on it's not a game structure, right? Like cards are. There's way too much going on here. It's called chaos theory. So there's chaos going on in that system. So you can't come up with rules of the game. So you just have to make educated guesses. Not to say that they're wrong, they might be right, but although quite often they're wrong. The same thing happens for, basically political pundits on pick your news channel, or oh, prognosticators about who's going to win the Grammy this year, and who's going to win, this award this year, the Oscars, and so on. What is so and so going to wear this year? Well, I think so and so is going to wear this designer for her wedding dress, for pick a royal wedding. All of that is subjective probability, because they're talking about events that are completely unreplicable. You can't replicate what's going to happen. It's this special event, and every year they have the Oscars, yes, but every year all the stuff that goes into making those Oscars is different from year to year. Who's the voters, and who are the nominees, and what's the political makeup, and etc. So it's subjective every year for all that kind of stuff.